Hello everyone and welcome back to Nunley Math. As always, I'm Aaron Nunley. Thank you so much for joining us here today as we talk about multiplying rational numbers. Now this lesson is going to involve a brief look back at some fraction concepts that hopefully you learned in 3rd, 4th, and 5th and 6th grade. But we're really gearing this towards 6th, 7th, and 8th graders, pre-algebra students who already have a certain amount of fraction knowledge. So even though we are going to be reviewing some concepts, we will be reviewing some things very, very quickly. So if you're brand new to fractions, this may not be the video for you. If you're already fairly familiar with fractions, certainly hop right in, follow along, and join us. We're glad to have you here. Now, I am going to go back very briefly and talk about this idea of multiplying fractions, and I'm going to do it very visually, that like you would have done hopefully in your primary education classes. Notice I have 3/5 times 3/4. What this says is I have 3/5 of an object, and it really doesn't matter what that object is. I find it's very helpful to illustrate this with a square, so I've got a square. If I wanted 3/5 of this square, remember the denominator of this fraction says split this into 5 equal-sized parts. And the numerator says we take 3 of those 5 parts. Now, because of the way this is drawn, you might think of this as being, I don't know, a large cake that's cut into 5 slices, and we used up 3 of those slices for our party or something like that. You could have also made this one long ribbon and cut it into 5 strips. You could have made this into a circle and cut it into 5 wedges. It really doesn't matter, but for the purposes of illustration, I find that rectangles work very nicely. Now, when I say take this 3/5 times 3/4, what I'm asking you to do is take this blue part, split it into 4 equal-sized pieces, and take 3 of the blue part. 3 out of every 4 pieces of just the blue. Now, that might be a little bit complicated of an idea, so let me show that to you. I want to take 3/4 of the blue. So I've got to cut that blue into 4 equal-sized sections. Notice the first time I cut it into sections using vertical lines. This time I'm using horizontal lines. 1, 2, 3, 4. I've cut this entire object, including the blue, into 4 equal-sized sections. And I'm going to take 3 of those equal-sized sections. Now, if I take just the blue that's been overlaid in red. Notice I've got 1, 2, 3 out of 4 equal-sized sections of the blue. Now, when I do that, this is what's really cool. 1, 2, 3, 4, 5, 6, 7, 8, 9 equal-sized pieces have been created. 9 equal-sized pieces have been created out of the 12 pieces that are created in blue. But our final answer should always be in relation to the size of the pieces and the number of them that's needed to make a whole. So when I look at these 9 pieces, these 9 pieces are all 20ths. The reason for that is because it takes 20 of them to make a whole. Think through that just real quick. 3/4 of 3/5 says we're going to have 9 equal-sized pieces out of the 12 that were created from the blue. That's 3/4. If I wanted to do this 3/4 in relation to the whole, I have 9 pieces that are all 1/20th of the whole. I've got 9/20ths of the whole. Now, hopefully you spend a lot of time doing that kind of an activity in elementary school. We don't have time in this video to do lots and lots of these, but I know that's a little bit complicated, so I am going to do one more for you. Hopefully it will make sense. Before I do that, I do want to suggest that you pause the video for just a second and look just at the 2 fractions and their product without the picture. Hopefully you can look at these and spot something that looks like it might be a rule. This time I'm going to do 2/3 of 1/4. 2/3 of 1/4. Or you could do it as 1/4 of 2/3. It's the same thing either way. Let's do 2/3 of 1/4. I've got a fourth, which means I take my object, split it into 4 pieces, and take one of them. I need to split this blue section into thirds. So I'm going to divide it into 3 equal size sections. 1, 2, 3. Now notice I extended my columns all the way down because I want my entire object to be same size pieces. 1/4 cut into 2/3 means I take 2 of those 3 pieces. My answer is going to be 2 out of how many of this size piece does it take to make a whole? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 2/12. 2/12. I have 2 pieces, and each piece is a 1/12 of an entire unit. Now, this is actually really cool as well, because if you know much about fractions, you should know that 2/12 is not in simplest form. It simplifies to 1/6. I can actually look here and see 1. Notice that's the 2 pieces I had before. That's my part that is double shaded. I have 2. The second one's the same size. 3. The third one's the same size. 4. The fourth one's the same size. 5 and 6. I can either have 2 pieces when it takes 12 pieces to make a whole, or I can combine those into one larger piece when it takes 6 of the larger pieces to make a whole. Now, I want you to look at your 2 problems again. Did the pattern you found up here also work over here? Did you see it? 3 times 3 equals 9. 5 times 4 equals 20. Over here, 1 times 2 equals 2. 4 times 3 equals 12. You see, rather than taking the time to draw these pictures out every time, if I can remember the rule, all I have to remember is that if I multiply the numerators together, I get the numerator. If I multiply the denominators together, I get the denominator. Let's look at a couple examples of this. Let's say I have -1/9 times 4/7. If you think you've got this, I'd recommend pausing the video, trying this one on your own, then restarting the video to see if you got the correct answer. The rule is multiply the numerators, multiply the denominators, and then simplify if you can. So in this case, -1 times 4 is -4. 9 times 7 is 63. There's your solution. I don't believe that simplifies. But notice I did move my negative sign from the numerator down into the front. Usually we find that it's easier when you're working a problem out to have your numerator up front or up top, but most of the time people are more comfortable in their final answer having it out front. The only place I don't like to have my negative sign is on that denominator, so please don't do that. It makes things a little more difficult in the future. Not too bad, right? I'd recommend, again, for each of these, pausing them, trying on your own, and then watching the video to see if what we're doing makes sense to you. I'm going to go ahead and keep doing these. I'm probably going to do them a little faster because you should be getting pretty good at it. -5 times 7 is -35. 14 times 8 is 112. Now, the question is, does this simplify? Well, I happen to know, let me switch ink colors here. I happen to know that -35 can be divided by 7, and I also happen to know that 112 can be divided by 7. When I divide those, I get -5/16. Notice again, I move that negative sign down in front. Some people get confused. Why am I allowed to divide by 7 just randomly in the middle of a problem? Well, if you think about it, 7 over 7 is the same as a 1. 7/7 is a 1. And I'm allowed to multiply and divide by 1 whenever I want because it basically does nothing. That's called the identity property of multiplication. Let me keep going. Again, pause this, try this on your own. I'm going to keep going. Negative 3 times negative 4 gives me 12. 8 times 9 gives me 72. I'm at 12 over 72. Will this simplify? Well, yeah, I know that the numerator can be divided by 2 and the denominator can be divided by 2. I can divide by 2 over 2 because it's a 1. That gives me 6 over 36. Again, this can be divided by 2. This can be divided by 2. That gives me 3/18. And I also happen to know that both of these can be divided by 3. Your final answer here is 1/6. Now, I know a lot of you probably already could have looked at this and said, oh, there's something bigger than a 2 that would divide into it. And certainly that is a faster way to do it if you can spot that. But for a lot of students, it's easier just to start with the 2 and the 3 and work our way through it. Again, pause the video, try this on your own. I'm going to do this one really quickly. This is negative 40 over 156. Both of those can be divided by 2 and by 2 again. And then I just move my negative sign out front. Not too bad, I hope. Now, I want to show you something that I think is really cool. I've recopied example 3 and 4 from the previous slide onto this slide because I want to show you something else we can do that might be a little faster for you, because this is really a long process, especially if you start getting some really big numbers like 156. That's kind of a nasty number to have to work with. If we can avoid getting big numbers, it usually makes our lives a whole lot easier. So let me show you a shortcut. Notice on this first problem, I've recopied it down here at the bottom, negative 3/8 times negative 4/9. If I were to look at the negative 4 on top and the 8 on bottom, I can look at these and notice that they have a common factor. Both of these can be divided by the number 4. In fact, I usually think of a number on top and a number on bottom just like I think of a fraction. Negative 4/8, which I know simplifies to negative 1/2, right through my ink arrow. That was sloppy, wasn't it? Because negative 4/8 is the same as negative 1/2, I can actually replace negative 4 and negative 8 with negative 1 and 2. Notice I have much smaller numbers to work with now. I'm going to do the same thing with this negative 3 and 9. I notice that negative 3/9 is the same as negative 1/3. So I'm going to come over here and I'm going to replace this negative 3 and this 9 with a negative 1 and a 3. And when I do that, now I can multiply the numerators together and the denominators together. Negative 1 times negative 1 is 1. 2 times 3 is 6. Notice I get the exact same answer. The difference is, instead of having to divide by 2 here, and divide by 2 here, and divide by 3 here, I actually divided by 3 right here, and I divided by 4 here, both those 2's. A little bit of a shortcut. It's easier to simplify when we've got small numbers like this than it is to simplify at the end. Let's do another one of these. I'm going to copy example 4 over. Again, if you feel pretty confident, I recommend you pause the video and try it on your own. I'm going to keep going. I'm looking on the top and the bottom for things that might simplify. In this case, I have a negative 8 and a 12. Well, I know that's negative 2/3. So I take those out, replace it with negative 2/3. I look at the 5 and the 13 and I notice, wait a second, those do not simplify, so I leave them alone. When I multiply, negative 10/39. Notice it's the same answer we got the first time. It's just a lot less simplification at the end. Notice up here at the top, it's easiest if we simplify first, then multiply the numerators and the denominators. One thing I should point out, you'll notice that what I'm doing here is I'm covering these with circles. Most of my students wouldn't have the ability to do that because they do these on pencil and paper. What I recommend is that you cross out whatever number is here and you write it above neatly. And that helps me keep track of things. It's not quite as convenient as the circles, but certainly without the computer, it's definitely a viable option. Again, as we go through these, make sure that you're pausing and trying them on your own before you just watch me. Watching me isn't nearly as helpful for you. Here's one, Negative 4/15 times negative 10/16. I'm looking for things that will simplify. Notice negative 4 and 16 is the same as 4/16, which is 1/4. Don't lose that negative sign. Notice that negative 10/15 is the same as negative 2/3. Also, one extra thing that I noticed, did you catch this? The negative 2/4 right here. This is now a fraction that will simplify because 2/4 is the same as 1/2. Don't lose your negative sign. Now I can multiply this together. I get 1/6. Again, I'm going to recommend you pause the video. I'm going to keep right on going. 15 over 45 is 1/3. Don't lose your negative sign. 18 and 27 is 2/3. Multiply it together, you get negative 2/9. And usually we put the negative sign out front. If you get a mixed number, make sure you make it into an improper fraction before you do this. Remember, 3 1/4 is 3 times 4 is 12 plus 1. That is 13.